Hello friends, in previous module we saw some basic definitions of fluid mechanics such as definition of fluid, then fluid mechanics, fluid kinematics, fluid dynamics, statics, kinetics, isn't it? Now in this lecture, we are going to discuss the properties of fluid. In this module, we will see only the four properties, that is the mass density, then specific weight, specific gravity, and specific volume. So before going to define these properties, I will again repeat the definition of the fluid. So fluid, it is a substance which is capable of flowing. It has no shape of its own, but conforms to the shape of the container in which it is flowed. It deforms continuously as long as shear force exists. So this is the definition of the fluid. And fluid possesses the properties such as mass density, specific weight, specific gravity, specific volume, viscosity, surface tension, capillarity, compressibility. So these are the various properties. In this module, we will see the first four properties, that is the mass density, specific weight, specific gravity, and the specific volume. Now, the first property, that is mass density or the specific mass. Now it is denoted as rho L. Rho L. Mass density of fluid is the mass per unit volume. Mass per unit volume. So it is the ratio of mass of fluid to the volume of fluid. So mass is expressed in kg, volume is expressed in cubic meter, and therefore the unit of mass density is kg per cubic meter. Kg per cubic meter. Okay. At standard temperature and pressure, the mass density of water is taken as, so rho W is equal to 1000 kg per cubic meter. Okay. So this is the first property. Now the second property is the specific weight. Specific weight, it is also called as weight density, sometimes it is also called as unit weight. Unit weight. Okay. It is denoted as gamma L. So the specific weight is the ratio of weight of fluid to the volume of fluid. So weight per unit volume is called as specific weight or the weight density. Now weight is expressed in Newton, volume is expressed in cubic meter, and therefore unit of specific weight is Newton per cubic meter. Newton per cubic meter. Okay. The specific weight of water and standard temperature and pressure is taken as 9810 Newton per cubic meter. Okay. So the specific weight is the ratio of unit per volume, weight per volume. So weight is expressed in Newton, volume is expressed in cubic meter. So unit is Newton per cubic meter. So gamma W is equal to 9810 Newton per meter cube. It is equal to 9.81 kilonewton per cubic meter. Okay. Now there is relation between. So let us establish the relation between these two. Okay. So we know that this weight is equal to mass into acceleration due to gravity. So weight is expressed in terms of like this, mass into acceleration due to gravity. So divided by a volume, and therefore, so this term, that is mass upon volume, is nothing but the mass density, rho L. So therefore, gamma L is equal to rho L into D. So this is the relation between these two terms. Okay. So we have established the relation between these two, isn't it? Now again I will let us discuss what is the effect of temperature and pressure on the mass density. So what is the effect of, let us discuss the effect of pressure and temperature on the mass density. Okay. So we know that mass is directly proportional to number of molecules. Number of molecules. It means that if the number of molecules are more, mass will be more, and hence if the mass is more, naturally the mass density will also more. Okay. So let us study. So this is a given volume. Suppose this is a given volume V, and by applying the compressive force, if we try to accommodate more number of molecules in a given volume, then naturally the number of molecules will increase. Since the number of molecules increases, mass is increases, and the mass density will also increase. That means by increasing pressure, Rho L will increase. Isn't it? So mass density will increase. By increasing pressure, mass density increases. Okay. Now let us study what is the effect of temperature on the mass density. So by increasing the temperature of a fluid, the number of molecules will escape from the surface into the atmosphere. It means that the number of molecules will go on reducing due to increase in temperature. And since the number of molecules are decreases, mass decreases, and therefore mass density will also decrease. Okay, isn't it? So due to increase in temperature, mass density decreases. And since the weight depends upon the mass, so whatever the effects of temperature and pressure on the mass density, the same effects are on the weight density or the specific weight. Okay, so this is about the effects of temperature and pressure on the mass density and the weight density. Okay, now the third property is the specific gravity. Specific gravity, it is also called as relative density. Relative density. It is denoted as SL. So specific gravity is the ratio of weight density of fluid to the weight density of standard fluid, and the standard fluid is taken as water, and therefore it is the ratio of specific weight of liquid or fluid to the specific weight of water. So gamma L upon gamma W. And now since gamma L can be written as rho L into G, this is equal to rho W into G. This G get cancelled, and you will get the specific gravity is the ratio of gamma L upon gamma W or rho L upon rho W. Okay. So since it is the ratio of two densities, that is ratio of same quantities, densities, and hence it has no unit. Okay. The specific gravity of water at STP is taken as 1. Specific gravity of mercury is taken as 13.6. It means that the mercury is heavier than that of the water. So water is light liquid and mercury is heavy liquid. So mercury is 13.6 times heavier than water. Okay. Now the fourth property is specific volume. Specific volume. It is denoted as Vs. Okay. So this specific volume Vs is the volume per unit weight of fluid. Volume of fluid to the weight of fluid. So it is the ratio of volume of fluid to the weight of fluid, and therefore volume is expressed in cubic meter, weight is expressed in Newton, and therefore its unit is meter cube per Newton. Now remember, it is the reciprocal of specific weight. So this means that this specific volume is the reciprocal of gamma L. Okay. This formula or this definition is applicable to liquids only. As far as the gas problems are concerned, or gas flow problems, this specific volume is taken as reciprocal of mass density, and in that case its unit is meter cube per kg. So in case of gas flow problems, the specific volume is taken as reciprocal of mass density. Okay. So this is about this today's lecture. Okay. So we saw the definition of mass density, definition of specific weight, then specific gravity, and the specific volume and their values. value of water, isn't it? And the relation between the mass density and weight density. Okay, so we will stop here. Thank you for watching.